So during this week, I'm going to discuss an important topic in the subject quality design and control, and this particular topic is referred to as acceptance sampling. Now during this week as well as in the next week, I'll be discussing on the various aspects of acceptance sampling. Now during this week, there are few topics I am going to discuss related to acceptance sampling. So in this lecture, I will cover the fundamental concepts in acceptance sampling, advantages and disadvantages of sampling. You must know in clear and specific terms what are these advantages as well as the disadvantages. The definition of certain terms like AQL, producer's risk, LQL, consumer risks, and we'll also discuss the types of sampling plans. In the next lecture session, I'll be referring to the performance measures of sampling plans. There are different types of performance measures like OC curve we'll discuss, ASN curve we'll discuss, how to construct the OC curve and the ASN curve we are going to discuss, and the concept of rectifying inspection with numerical exercises we are going to discuss in the next lecture. During third lecture session, again we'll be referring to the performance measures like say AOQ curve and ATI curve, construction of AOQ curve and ATI curve, and how to design a sampling plan, and numerical exercises also will be referring to. In lecture 4, design of single sampling plans will explain in detail. Numerical exercises, special purpose sampling plans like chain sampling plan, sequential sampling plans, and sampling plans for continuous production. So this will be our coverage during lecture 4, and in the lecture 5 we'll be discussing in detail the standard sampling plans like military standards 105E or equivalent ANSI ASQC JED 1.4 standards or equivalent ISO 2859 standards. So this will be our coverage. Now let us first talk about in this lecture session the fundamental concepts in acceptance sampling, advantages and disadvantages of sampling, and we'll be referring to certain terms and terminologies related to acceptance sampling, and you also must know at this stage what are the definitions of all these the terms and terminologies like AQL, LQL, producer's risk, consumer risks, and at this stage also you must know what are the types of sampling plans you may come across. Now, acceptance sampling is considered a major component of quality control. That means whenever you go through a topic called quality design and control, or suppose right now we are going through the subject called quality design and control, the acceptance sampling is a very important the concept you must be aware of. And among all the tools and techniques that you are going to learn or that already you have learned, you will find that the acceptance sampling techniques are widely used by almost all the organizations. Okay, and related to acceptance sampling, there are many standards already being developed. Initially, these standards were developed by many military organizations during the Second World War days, and later on these standards with modifications for obvious reasons were adopted by organizations producing civilian products. So all these details you must know, and you will find that almost majority of the cases that the acceptance sampling, the technique you have to adopt. However, you must also keep in mind that it is not considered a quality improvement tool. Is it okay? There are two aspects in quality design and control. One is definitely the controlling part. That means whatever the quality standards you have specified and you are trying to achieve, whether you are achieving those standards or not. So that is basically the domain of the quality control. Whereas it is a constant endeavor on the part of management to improve the quality of a product or a process. So what are the tools and techniques you need to use? It's like say the Taguchi method or some other quality improvement tools later on you will learn. So those definitely offline quality control, the tools and techniques you may adopt, you may use for quality improvement. But here acceptance sampling is not a quality improvement tool. So this point you also must keep in mind. In acceptance sampling, inspection is performed on a lot or a batch or a shipment of components. Is it okay? So what is acceptance sampling? What actually you are supposed to do under acceptance sampling? That I am trying to explain. So it is essentially an inspection activity, but the inspection is performed on a lot or a batch or a shipment of components. And what you are trying to do, that means you need to take a decision. Suppose you receive a lot of components, right? Now you have to take a decision whether the lot will be accepted or lot will be rejected based on the level of quality that you expect in the units of the in the lot. So samples. So what you try to do, that means in the acceptance sampling, you do not the check or inspect each and every item or each and every unit in the lot. So a sample is drawn, either one sample or in certain cases more than one sample you need to draw from the lot or the batch. So the samples are drawn from a lot and a certain quality characteristics of the units are inspected. Is it okay? That's basically the inspection activity. A decision is made based on the inspection of the samples. That means when you get the sample, you go for 100% inspection of the sample units, and then you get the inspection result. Now based on the inspection result, you have to make a decision whether you will be going to accept the lot or you will reject the lot. So ultimately it is considered to be an auditing tool, or it's just as a screening technique. That means I need to take a decisions on lot acceptance or lot rejection. Okay. So depending on the conditions encountered. Now this is the basic technique you follow in acceptance sampling. Now this technique you have to follow not only in the same conditions but under the different conditions. So depending on the conditions encountered or the situations in which you need to apply this technique, and objectives and the types of quality characteristics come across, right? Varieties of sampling trend can be designed and used, and so far the researchers or the practitioners, they have proposed different kinds of sampling plans suitable for under the different conditions. Is it okay? So the varieties of sampling plans you come across, obviously in a textbooks on the quality or in a specific textbooks on acceptance sampling, you will come to know the classification, the scheme for all these say sampling the plans or the sampling techniques being used. Now whenever you say that the sampling or the acceptance sampling technique is being used, that means it is considered to be an alternative to 100% inspection. So as an alternative to 100% inspection, sampling inspection is suggested. That means your first preference may be 100% inspection, but in many times you will find that the 100% inspection is not necessary. If it is a very critical component, like say the medicine, okay, and suppose a particular medicine is being produced in large numbers, or say suppose it's a baby food, okay, so each and every the unit you need to inspect. Is it okay? So you cannot take a chance, and you must go for 100% inspection. Is it okay? Or say the components, the aircraft components, each and every component is to be inspected. Is it okay? That means even if each component is produced in large numbers, make sure that each component or each item or each unit is inspected. So, but barring those cases, you come across several situations where the component may not be that critical. So whenever the component is considered not critical, and in actual the scenario what you will find, the such components you come across with large numbers. What you try to do, that means you think of alternatives. So alternative to 100% inspection is sampling inspection or acceptance sampling. Yes, there is a risk involved, but if you can design the sampling plan in such a way that the risk is at the minimum level, obviously you say that 100% inspection is not necessary for such items, and acceptance sampling is may be considered to be a very reliable say inspection tool. So sampling inspection is suggested under those situations. There are several situations you may come across where the parts may not be important or critical to performance. This point I have already elaborated, and 100% inspection is not necessary. Acceptance sampling as a method is cost effective. Is it okay? That means instead of it's very clear, that means instead of inspecting each and every item in the lot, okay, what you are doing, you are just getting a sample, and sample is a representative sample, and so in many a time what you find that the sample size is compared to the lot size is very less. Okay, that means in many a time later on you will find with examples that the lot size is at least 10 times more than the sample size. So but what you are trying to do, that means you get a sample and make sure that while you form the sample, that the sample is representative of the population or the lot, and then you go for 100% inspection of the sample. So the time taken for taking a decision regarding lot acceptance rejection is substantially less. So that's why it is a very cost effective method. So certain items, the inspection time could be very large. So what you try to do, that means you try to reduce the inspection time, and obviously one technique could be the sampling inspection. However, there is an unavoidable risk involved. That means this risk you cannot avoid because of the very nature of sampling. A good quality lot may be rejected. Is it okay? It may so happen that even if there are few number of say non-conforming units in the lot, but when you produce, when you get a sample from this lot, maybe all those the non-conforming units you may find in that particular sample. So obviously, you may consider the sample quality could be extremely bad, and that's why you may reject the entire lot. So what actually you are doing, that means a good quality lot you may be rejecting, and similarly alternatively a bad quality lot may be accepted. That means in the lot there is a large number of non-conforming units, but when you get the sample, because of the very nature of sampling, you may not find any number of say the non-conforming units in the sample. So what you say, that the sample quality is very good, you may conclude that the lot quality also may be very, very good. But this conclusion could be wrong. So a bad quality lot may be accepted. So this possibility remains. So you need to design a sampling plan in such a way that these risks are held at minimum. Is clear? So when we discuss the sampling, the design, that is how to design a sampling plan, will you refer to these points. Now it is used between two parties. That means whenever you say that the acceptance sampling technique is being used, there are two parties involved. So what are these two parties? That means the supplier and the manufacturer. That means the supplier is supplying a lot or the batch of items, and he is giving it to he or she is giving it to the manufacturer, and what the manufacturer decides that as it deals with non-critical items, so it is better to opt for acceptance sampling technique. Is it okay? So he applies or he said that this particular sampling plan he is going to use. Okay. Similarly, between the two shops, say the shop A and shop B, that means shop A is the supplier and the shop B is basically the customer. That means the item is getting produced at shop A, and before that item is used at the shop B, so the shop B personnel may be using the sampling techniques. Okay, so whenever you say that the sampling technique is being used or acceptance sampling plan is being used, immediately you assume that there are two parties involved. Acceptance sampling is recommended in the following situation. Testing is destructive. There are many cases. Is it okay? So obviously you cannot go for inspecting each and every item in the lot. Is it okay? So if the testing is destructive, in the process of getting the data, you will be losing all the items in the lot. So that is not just acceptable. Cost of 100% inspection is very high compared to cost of allowing a non-conforming unit uninspected. So this sort of the data you must have in a given situation. So obviously your obvious choice is, why don't you go for sampling inspection or say acceptance sampling. 100% inspection is not feasible. It may make the process very slow as inspection time is substantial. Is it okay? So this is the third reason. Inspection of similar items. Is it okay? So when you look at the item, you'll find is almost similar. Is it okay? So why do you test all the items? Is it okay? So it's better that you just select a sample, right? Similar items. Inspection is manual and not automated. You know, these days what you'll find, many organizations, okay, for maintaining a very reliable say inspection systems, they go for automated inspection, and where the production rate is very high and 100% inspection is a must. So when the inspection is manual, now if it is manual and the production rate is very high, that means per unit of time you need to inspect a large number of items. Will you prefer 100% inspection? If the inspection is manual, there is a chance that there could be, you know, the human error, and the data you get may not be reliable. Is it okay? So what you try to do, it's better you ask the person to inspect a fraction of the items, and while you go for inspecting a fraction of the item, the total number of items, obviously you are creating a sample. Excellent quality history. Is it okay? So it's highly dependable. So you say just you check a few items from the lot, and if you find these items are of acceptable quality, why don't you accept the lot? Inspection has to be done because of potential serious product liability. So sometimes knowing fully well that the lot quality is excellent, but then again you have certain restrictions. That means certain liability you have to show certain data to the regulating agencies or regulating authority. So what you try to do, that means you go for a sampling inspection or acceptance sampling. Information related to quality is not available. Is it okay? So if it is not there, obviously what you go for, you must go for sampling inspection, right? Now, what are the advantages of acceptance sampling? It is economical, less inspection and fewer personnel. That means when you find that the inspection the time is very high, is it okay? Will you opt for inspecting each and every item in the lot? Probably not. So and if you opt for even under such case, such conditions, suppose you opt for 100% inspection of the lot, the whole process becomes uneconomical. It requires less handling and hence less damage. Is it okay? Because you are not handling all the items in the lot, you are just handling a portion of lot units. Results are more reliable as there is hardly any human error. So this is the point to be noted. I have already referred to say the human error component. That means if human error may set in while someone inspects the items for a longer period of time. Motivation for suppliers to improve quality. That means they say that there is a chance that even the good quality may be rejected. Is it okay? So they know it very well. So obviously you will find that if you follow the acceptance sampling technique meticulously for a longer period of time, there is a positive effect on the performance of the suppliers. But along with these advantages, there also might be certain disadvantages. So what are those disadvantages? So the disadvantages are few. Risk of rejecting a good lot, that is referred to as the producer's risk. This is there because of the inherent nature of sampling, or risk of accepting a bad lot, that is referred to as the consumer risk. So what you need to do while you design a sampling plan, these are known implicitly. So while you design a sampling plan, you make them explicit, and you design the sampling plan in such a way that the producer's risk and the consumer's risk, they are held at the minimum level. Less information about the lot, obviously, because if you collect quality related data, say related to all the items in the lot, obviously your information base will be is stronger. But here what you are trying to do, you have the information only on the quality of a sample, okay, and this sample you have drawn from the lot. So you have less information, more effort and time required for its adoption, because whenever you study a particular sampling plan, now you need to know the procedures, and in certain cases, particularly when deal with the special purpose sampling plans, so you must be well trained. Is it okay? So there is an administrative cost associated with implementation of such a plan. Is it okay? So these are the disadvantages. Now let me first define certain terms and terminologies you come across while you study this particular topic. So the definitions of AQL, LQL, producer's risk and consumer risk. So these four the terms, let me first explain. AQL stands for acceptable quality level. So what is the definition of acceptable quality level? Acceptable quality level indicates a level of quality which is considered to be very, very good. The maximum percentage or proportion of non-conforming items or number of non-conformities in a lot or a batch that can be considered satisfactory as a process average. That means whenever you say that I have specified the value of AQL, that means you are specifying the level of quality considered as very good and acceptable. Is it okay? But this is as a process average. That means whenever dealing with not only one lot, the several lots, that means the concept of AQL is applicable. And this definition is given as per the JED 1.4 standards. Similarly, you have the limiting quality level indicative of bad quality. The percentage or the proportion of non-conforming items or the number of non-conformities in a lot or batch for which the consumer wishes the probability of acceptance to be a specified low value. Also referred to as rejectable quality level, different terms you use, different names, unacceptable quality level, UQL, or simply limiting quality. So this definition is also as per JED 1.4 standards. Later on we will be discussing this particular standard. When LQL is expressed as a percentage of non-conforming, it is referred to as LTPD, lot tolerance percent defect. This term you come across in the manufacturing the organizations. Okay, they may not be telling you about, they may not be using the term limiting quality level, but they may be using the term called LTPD, lot tolerance percent defective. So it is essentially a manufacturing systems the coin term. Now what is producer's risk? Producer's risk, that is alpha. This is the risk associated with rejecting a lot of good quality. That means it is to be defined with respect to AQL. It's clear. That means first you specify AQL and then you say this is the producer's risk. That means even if the quality is at AQL or less than AQL, but the probability of its not acceptance is alpha. Similarly, you have consumer risks. This is the risk of accepting a bad lot. That means quality is very, very poor. That means how do you specify this bad quality? That is, you specify by LQL. That means any value greater than or equals to LQL is considered to be very, very bad. It is seldom desirable to accept lots with such a quality level. It is to be defined with respect to LQL. Okay, suppose someone explains the term alpha and beta, but he or she doesn't mention about AQ or LQL, so it is so his definition is not complete. So an example, it is stated that the producer's risk is 1% for an AQL of 0.02. It means that the lots with 2% non-conforming are considered good, and such lots must not be rejected more than 1% of the time. Similarly, if it is stated that the consumer risk is 5% for an LQL of 0.12, it means that the lots with 12% non-conforming are considered bad, and such lots must not be accepted more than 5% of the time. So, the types of sampling plans, there are, as I have told you, that there are many types of the sampling plans you may have to use, and over the years the researchers, the practitioners, they have developed many types of sampling plans. Now why do you and these the types of sampling plans can be classified based on the several the criteria. So the first one is the classification based on types of quality characteristics. Attribute sampling plans, that is one type, when you deal with the attributes data. Is it okay? We have already mentioned when we deal with the control charting in statistical quality control or statistical the process control. Similarly, when you deal with the variables data, you have the variable sampling plans. So maximum number of samples allowed to be drawn from the lot or batch, like we have single sampling plan, just one sample you have to draw. Double sampling plan, maximum 2 numbers, and multiple sampling plan, more than 2 samples you can draw. As per JED 1.4 standards, maximum of 7 samples you are allowed to draw. So whenever you refer to these standards, we will mention this. Then you have the special purpose sampling plans. When you come across special cases like rectifying inspection, we will define what is rectifying inspection, inspection curtailment, small sample size, lots cannot be formed, there are cases, but you have to use the sampling plan. So those are basically the special purpose sampling plans and continuous production systems. So this will be, so the classification scheme you must be aware of. So along with those AQL, LQL, producer's risk, consumer risk, we have used several other terms and terminology. In subsequent lecture sessions, we will be referring to, we will be discussing those terms and terminologies.